Okay, gotcha. All right, cool. All right, so basically the whole point of construction is to take, a raw piece of land and convert it into some useful function, right? In putting up a building, a bridge, a road, whatever it is. And particularly in the civil realm, the civil engineering realm, where you're grading and like building a site to the point that you can make some improvement on it, whether that's a building or a bridge or whatever, you have to disturb soil. And when you disturb soil, you take out, you look up on this hill, you've got grass and trees and shrubs and all that. When you remove that, you make that soil vulnerable to erosion. What happens when it rains on the bare soil, it erodes the soil, brings it down, makes the water look like chocolate milk, and eventually runs off into whatever storm drain systems, creeks, streams, whatever are adjacent to your project, and ultimately, for this area, down the river and into the delta. So either the American River, Sacramento River, and so our whole point is to keep that dirt, those pollutants, potential pollutants, out of those waterways. So way back in the 70s, about the time I'm guessing your parents were born, the federal government passed, for a lot of you, freshman, sophomore. So in the 1970s, they passed the Clean Water Act, and one of the provisions of the Clean Water Act was to prevent the type of erosion and water pollution that I just talked about. So there's a whole provision in there on water quality related to construction activities. And then over the years, the regulations have evolved, and the state of California has a statewide permit with the federal EPA, basically prescribing all of the measures that we will do in construction to protect the water. So what it's called, we call it for short the Construction General Permit, or the CGP. And if you're on any job that disturbs more than an acre of ground, you're going to be dealing with the requirements of that Construction General Permit. So things that the permit addresses really two major areas. One is, how do you protect the water quality during construction? So once you strip that vegetation off and you've started grading, how are you going to keep that project safe and not polluting while you're building it? The other aspect is, they call it post-construction. So as you can imagine, we have, 2 acres of concrete slab here now? Something like that. When rain falls on this project, now that it's covered with impervious surfaces, right? Surfaces that don't absorb water. So we have soil over here, and as Adam mentioned, this is lime treated, so it doesn't absorb a lot of a lot of water. But typically, soil is going to absorb a lot more water than a hard impermeable surface like a roof or a concrete slab or asphalt. So what happens when it rains, the water hits this project, it runs off a lot faster than it would if it was covered with soil, or particularly with vegetation. So there's called, when you guys study hydrology, or probably in your soils class, you're going to learn about what's called a peak flow runoff curve. And what that basically does is it describes how fast the water leaves the site once it starts raining. So a raindrop hits this ground, how long does it take for that water to get off the site? And there's a curve that shows like how long that takes, and it varies by the soil type, by the amount of impervious surface and all that. But one of the post-construction requirements is to minimize the steepness of that curve, so that you don't get basically a flash flood. Okay, a flash flood when rain comes and the water just bolts out really quickly. And you guys have all seen videos of that, because in the last month there's been quite a bit of that, especially down in SoCal. So when you design a project, how many of you guys have heard of LID or LEED? Okay, so you have some familiarity. So the idea of LID is an acronym that stands for Low Impact Development. And then LEED is just more of a proprietary certification process to show that you're doing low impact development. But there's a lot of overlap with LID requirements with what we're doing with the post-construction requirements, which is basically to make sure that when your project is done, you haven't negatively impacted water quality by the very act of building what you built. So on this project, you can't see them because they're buried now, but there's 3 stormwater vaults at the end of each of these driveways. So there's one in that corner, one in the middle, and then one in the far corner. And what these vaults have cartridge filters in them. And what they're designed to do is when it does rain here, the water will go into those vaults, and what that does is it flattens the curve. It throttles or funnels the water so that it leaves the site at a lower rate than it would otherwise. So the water runs off the gutters of the building, goes into the vault where it slowly builds up, and then it discharges out of a smaller pipe. So it basically meters the flow off the site. So it slows it down, it flattens that curve, but then it also has filter cartridges in it that absorb hydrocarbons, which is the main pollutant that the long-term impact of this site is going to have, because you're going to have tons of vehicles coming in and out of here. It's a self-storage place, so people are going to be, dropping stuff off, picking stuff up, moving in, moving out. There's going to be hundreds of units here. So there's going to be a lot of traffic, and just the oil, coolant, whatever fluids, even brake dust, that comes off of vehicles. And this is an issue with all parking lots. When it rains, all that stuff washes into the stormwater, and basically, it becomes polluted. So when the water leaves this site, it's going through these vaults, through cartridge filters inside that are built inside the vaults that absorb the hydrocarbons and other pollutants, and then discharges clean water. So that's the post-construction aspect of it. The during construction is particularly now on this site, because we started grading in like late September, early October, which is really kind of the start of the rainy season. This job was particularly vulnerable because, as you can imagine, everything you see that's concrete and cinder block right now was all bare dirt. And we have very little room to filter it. So what we really had to do was try to contain as much of the stormwater as we could on the site, because you can tell once it rains on it, it gets dirty, and we can't let that go. So what you can't really tell, and I don't know if we're going to walk through the mud, whatever, but I'm not going to drag you out there. But if you guys are walking around later, you can kind of see over the bank we have some perimeter controls in there. So I don't know if you've seen around construction projects the straw logs. They're called wattles. That's a sort of proprietary name. Their generic name is fiber roll. But you'll see fiber roll, you'll see silt fence, which is that usually black or orange fence. It's about knee high, and it's buried in the ground. And what it's designed to do is to catch, runoff before it leaves the site. So we call those perimeter controls. There's also another component is we call, and this is really the ounce of prevention is worth a pound of cure. The situation is erosion control or source control, which is you try to keep the water clean, try to keep the soil in place on the site, so you're not trying to clean dirty water downstream, once it starts flowing. So, excuse me, because this job has so much slab, has so much hard surface, we're now 2/3, 3/4 covered over the bare soil that we had before. So the situation is a lot better. The runoff off the slab is clean. And then the dirt areas, as we talked about before, are lime treated, and that actually compacts and hardens the dirt, so it's less vulnerable to erosion. So that's sort of what's been done for source control. It's a tricky job to pull off in the winter because you're going to have some exposed dirt, and ideally, you're able to cover all your dirt. But this job can't be built while dirt's covered because equipment needs to move around and all that. So it's an exercise right before every rain event. We're scrambling to get things into place, to protect the water as much as possible. You'll see like the big stockpile behind you. That's an example of source control. So even though there's a few gaps in there that Chris is going to fix later today, that plastic is designed to protect that soil there, right? Because it hasn't been lime treated, it's particularly vulnerable to erosion. When it rains on bare dirt and stockpiles like that, it runs right off. The soil just comes right off and runs downstream. So that's an example of how we try to protect soil. So do you guys have any questions? I try to cover a lot of stuff pretty fast, so I don't know if, yeah.
So were the vaults?
Pardon?
Were the vaults, the water vaults?
Yeah.
Were they constructed before you began?
So the question was whether the vaults were placed before you do any construction. So that's kind of a tricky thing because they're really designed for the post-construction state of the project. They can sometimes be incorporated to help filter the water that's generated this water during construction. We have these particular vaults offline because we felt like the dirty water here, there's so much sediment in it that it was going to plug up the filters. The filters are more designed for like picking up vehicle fluids and those kinds of pollutants. They're not really optimized for picking up sediment. So we've just kept them offline, and the storm drain system on this project right now, the underground system, is plugged.
And that's a good question. There's a little backstory on this project. We first bid this project in May thinking that we were going to start in June because the owner said, oh yeah, we've got all the permits ready. So we started to pull the permits and we didn't have the grading permit, which is obviously the first permit that you need. So we went to the county and we said, what's the holdup? They said, you guys need to put in a detention or a retention pond, which on a big job site, if you have enough room, you can put a detention or a retention pond, and that captures all your water. It either drains into the ground or it travels over like a dam structure, right, to get rid of all the sediment, retention or a detention pond. But obviously something like this, there's no room. And the owner of a storage facility is not going to give up square footage, put a pond on site, right? That's extremely expensive. But so were the vaults. So the civil engineer in the county came up with these vaults. It was like $100,000 extra to buy these special vaults with filters in them. But we went ahead and ordered them right away, thinking that we were still going to start this project in the summertime. And unfortunately, that permit didn't get issued until September or October. And we finally got started. And there were people on this project, our grading sub, that told us, like, you guys shouldn't start. They wanted to wait until the springtime. And we're like, well, we can't wait, right? The owners, they want us to keep going. They want to get this project done. We want this project on our books. So we started anyways. We really had to resequence a lot of things on this project to keep moving. So typically, if we were to start in the spring or summertime, we would come in, we'd do all of our site utilities. So a project like this, there's not a ton of utilities, but there's a lot of fire water, right? It's a storage unit. So every storage unit has sprinklers in it. There's fire hydrants scattered around the site. So there's a ton of fire water. There's a little bit of sewer coming from the office. That's this wood structure over here that they're building. And then there's also stormwater. So we're able to get the stormwater and the sewer in, but we're going to make the site Swiss cheese by getting all of our fire water in. You can imagine all the fire water is all these piles here. So we couldn't pour concrete. We couldn't get started on all these things that you see today. So what we did, we stubbed utilities into all the building. all the buildings, and we still don't have our fire water here on site yet. So we're probably just gonna wait until springtime. We're gonna keep going vertical with our buildings. We're gonna keep framing. And then once the weather clears up enough, we can have our utility subcontractor come in, and he's probably gonna start on one half of the site and get all the fire hydrant water and all the fire water in, and then we'll open up this drive aisle again, and then we'll move everything to the other side. That way construction crews can keep working. But typically, you want to get all your utilities in first. This project's unique that we haven't done any of our fire water yet. And there's actually an El Dorado County code or ordinance that any building type like our office, any wood structure, you have to have your fire hydrants in ahead of time. And we obviously don't have any fire hydrants in. There's an existing one over here on the corner of the property. And so we asked the fire marshal, we said, hey, we don't have our hydrants in yet, but we've got one over here. We came up with a nice logistics plan that shows, you know, in the case of an emergency, if this wood building was to catch on fire, the fire department still has access to water. And they said, okay, you guys can keep moving. So that's another good lesson in communication, right? If we tried to be cowboys or sneak one past the goalie and go ahead and start framing this without coordinating our fire plan with the department, they could have red tagged us and made us stop. So that's another good lesson. You know, you want to keep you know, all of your inspectors and, you know, the county or city, whatever jurisdiction you're working with, you want to keep them in the loop and, you know, make them feel part of this project. So anything else to add, Mark?
Unless you guys have any questions.
Any other questions for Mark? We're going to let him go because he's extremely busy. What's to do every time before and after it rains? How often do you have to?
So, yeah, actually there is one thing I want to add.
Yeah.
So, under these permit requirements that I talked about in the beginning, there are requirements of what they call monitoring requirements for during construction, and that's what I do for Headwaters right now on this job. And that is, before every rain event, if forecasted, there's, you know, rules about which forecast you look at and the percent chance of rain and all that. But before every forecasted rain event, I have to come out, walk the site, look for things that are out of place, damaged, particular vulnerabilities to water quality, communicate those to the superintendent so that he can prepare, fix, and be ready for the storm event. Then I have to be out here every day that it rains and actually watch and see if we call them best management practices, the silt fence and the plastic over the stockpile, the things that we do to try to protect the water quality. They're called best management practices, or BMPs. So I inspect to see if the BMPs are functioning, and then I also sample the runoff. And there's certain permit requirements about how dirty the water can be, what the pH level should be, and that. So I test that, and then I file reports. And there's an online database that the state of California Water Quality Control Board administers that I have to upload that sampling information to, which is a public database that you can go on and look up a job and see what's going on that job. Anybody can, and the public can do it. And so then we also have to do post-storm event inspections to basically assess any damage and make prescriptions for repairs or changes in BMPs that we need to do to improve things. And in order to do that, the way the state of California works now is that you have to get a certification. And, you know, if you guys go into construction management, that might be something that, you know, that you consider. There's what they call an industry certification, and then there's also the actual certification you get for the water board, which is called a QSP, or Qualified SWIP Practitioner. And then there's a higher level one called QSD, which is Qualified SWIP Developer, which allows you to write the plans for the projects, get the permits, that sort of thing. The QSP, the first one, is the certification you need to do the inspections, the sampling, and that sort of thing. And if you have that certification, that's a value added that you could bring to an employer, because if they can use somebody in-house who already has the certification, they don't have to hire an outside consultant like me, which is a waste of money. So, any questions about that? Okay.
All right, Mark. Well, I appreciate it.
All right.
We'll continue a brief tour of the job. Pretty substantial retaining walls on this side. They're not backfilled yet, meaning we're going to take all this dirt and all the dirt that we take out when we excavate for our fire water, and that all gets put on the back side of what we call building A over here as backfill. And so it's actually, there's a pretty substantial waterproofing aspect on this job. We'll try to walk around that. We'll look at that. We'll look at, this job's also unique. At Headwaters, we do a lot of storage stuff now, and you have very unique partitions and storage systems. So for anybody that's done metal or wood framing, typically you frame 16 inches on center, right? Just like this office, you can see all the studs are 16 on center. You know, it's pre-engineered. You have UL listings for that. With storage units, you don't have that. They're 4 or 5 foot on center framing, and they just get one side. Very simple. We have one project in Roseville. We're doing a multi-story storage structure, and then Spectre cannot wrap his head around this framing. But it's all pre-engineered. It's all prefab. So these guys on these metal buildings started last week, believe it or not. So after today, they'll be here for 2 weeks. That's including rain days. They're going to start laying down roofing on this building. They already have one building that's essentially done over here. They have to put the paneling on it, but it's all prefab. It's super, super fast. I think overall they'll have all these 4 buildings. We have one more building going down over here after that soil gets backfilled along the retaining wall. And all in all, they get done in about 3 months. So super fast system. It's very low cost. So unlike a lot of jobs that we go to this semester, if it's a hospital or hotel or something like that, that costs several $100,000 a square foot construction cost. A project like this is about $100 a square foot. So very, very inexpensive. And that's for everything, right? Utilities, concrete, CMU, framing. So any questions? We'll get started and look at the retaining walls.
Oh yeah.
What's that? Yeah, you get lights. The folders supported. Everybody's supported by the overall structure. There's nothing really hung on the wall. All the framing. They get one side of metal panel, but it's very unconventional, right? Usually you have 16-inch on center framing. You're holding up drywall. You know, you've got electrical spanner brackets and stuff in the wall, plumbing, other things that's supporting it. But with storage, you're just supporting one wall for each unit. So they frame this out. The coiling door people come in, they install coiling door and all the filler panels. There's a whole gutter system that gets installed. But it's very, very simple. It's very, very inexpensive. So let's see if we can sneak around this way. Pull into this. So you can see all that soil that we have stockpiled back there is all going to get backfilled. And you can kind of see this layout here. And that's the layout of all of our backfill. So all of that soil eventually, this is all going to get regraded. And this line here is the primer for the waterproofing. So this will get 2 waterproofing layers, 60 mils of waterproofing, and then it gets a drainage mat. And then like the detail that you guys have seen in our class, and hopefully the other class too, it'll get a drain pipe at the bottom, covered in rock, covered in filter fabric. And then we'll let our grading sub come back on the site and he'll grade all this out. So I'm sorry, probably not everybody can hear me, but. Stop this project, but it went through entitlements, we have our permits, everything else. Had nothing to do with us, it had to do with the development. What we saw very early on is these planes, they taxi out to the runway, their wings actually extend over onto our property line. So originally we were gonna have fencing here, and we kind of threw the airport a bone. We said, okay, we're gonna get rid of this fence. We have a block wall, why would we need a fence? Right, so they're really happy about that. We tried to be good neighbors with them, right, because they've got airplanes running all the time. There's actually an airplane that crashed a few weeks ago not far from our job site. So it's definitely some unique things out here. We do have to let them know anytime we have a crane on site or we had our concrete placing booms, we got to put special flags on top with beacons. They actually go onto the radio, and anybody landing here on their planes is notified that, hey, they've got 60-foot tall placing booms on site. There's an obstruction 60 feet off the runway or whatever. And it doesn't seem like a big deal, but if you see some of these small planes land, they get blown around in the wind, and it's not as these types of planes are not as safe as the commercial ones that you guys fly in. I'll just leave it at that. So, any questions? Sorry for you guys. We talked a little bit about the backfill and the waterproofing here. Yeah. Does the airport have? So the airport is actually a special district. So they get to collect like fees and taxes to operate as an airport. and that's what they run off of. So all these houses back here, you can see there's actually a couple streets over. All these houses, a lot of them have hangars in them. So there's these super wide streets. One street over, they have special streets that are like 100 feet wide, enough to get 2 airplanes taxiing. So these actually have, there's a ditch over here where that red plate is. You can actually drive down this road, and there's like a whole neighborhood of these super huge streets where these planes have access to go park in hangars, or some of them just keep them in their driveway or like on their lawns. It's kind of wild. It's like nothing I've ever seen before. But if you're super into aviation, you can literally step into your plane in your garage, open up your hangar doors, you know, kind of like the house back here, and fly right out and go to your job in the Bay Area, or you know, go fly around, whatever you want to do. On the airport on this side, which in theory should be secure, there shouldn't be too much riffraff on the airport. We're also pretty fortunate that there was already a fence here. This was used for like RV storage. So we had a pretty hefty fence budget. I think we had around like $13,000 budgeted for temporary fence for around the job site. And we ended up not needing it because we don't need fence on the runway side because, again, there should be enough security around the airport so that there's not too many people walking around the runway. And then on this side, there's an existing fence. So that's in our grading subs scope to take out. And we told them, hey, let's not take that fence out yet. Let's wait on that. So that's probably it for security. We have fencing. Fortunately, we don't have any cameras. We haven't needed them yet, or any on-site security. Other, temp measures or temporary construction. I would definitely say lime treating the soil. So you can see right now it seems wet and mushy, but before we did this, we had a couple rain events, and it was like a foot thick of mud, and you would walk back to the trailer and you'd have 6 inches of mud on the bottom of your boots.
So for the fencing, would it be purchased or rented?
We would have rented the fencing. Yeah, we've got a small yard at Headwaters, but we don't really have a whole lot of room to buy and store fencing. Have our guys set it up and take it down. A lot of times it's cheaper and easier just to pay a company. We have our standard temp toilets. Right now they're moved all in the corner of the job site, but as we're doing different activities, like when we were pouring concrete slabs, we move the toilets around. We have a generator. We're on generator power, so a lot of your job sites will probably talk about switch gear, right? So like the very first thing we did, we got our contract, and the next day we ordered switch gear because we can't have permanent power on site until we have our switch gear and transformer from PG&E. So we're on generator power right now that powers the trailer, and then all these guys' tools and stuff. So it's really expensive for us to run the generator. We have to fuel it up with diesel at least once a week. So as soon as our switch gear gets here, we're going to tie in our permanent power, and then we can run off that, which will be substantially cheaper. But overall, we run these jobs super lean, right? This isn't like a high-rise job with a tower crane or anything. This is like a quick and dirty. Like I said, we started this job in October. Our contract is to be done in August, but I'm hoping we get done like June. All right, with that, we'll go walk over here. I'll show you guys a concrete wall, similar to what we talked about in class today. And then if you guys have any other questions, let me know. Side of this wall, we actually backfill this with 12 feet of dirt. So that all gets waterproof. For those of you guys that didn't hear me on the other side, we've got the primer down now. We put down 2 layers of liquid membrane waterproofing up to 60 mils. And then we cover that with drainage board. We put drain pipe and drainage fill on the bottom. And then we backfill with 12 feet of dirt. So this is a pretty substantial retaining wall. The structural engineer has it designed. So the corners here, where it's retaining the most soil, we actually have a concrete stem wall. And you guys can see, we talked in class today, or in my class, about form ties. You can see the little holes, right? So these don't have to have any sort of special bracing or anything like that. They have their form arc, their whalers, and their form ties. And then after they strip the form, you have these little holes, they patch them, and they're done. So a pretty cost-effective forming system. All right. Well, with that, that's pretty much it. You guys, yeah.
What's the crew size on like a job typically every day?
Okay, so this company that's doing the self-storage, they're called Kiwi, and they're called Kiwi because they're actually from New Zealand. So it's funny, you talk to the estimator and their office people and they have like a New Zealand accent, but for whatever reason they moved here and they started a self-storage partition company. So they've got 7 guys. Our framers, we've got about the same, wood framers, 7 guys. They actually started that last week as well. So you could see they'll be done next week. So in about 2.5 weeks, they'll have that whole office, that wood structure framed. So that's company's called Kiwi. Our framer is called Gemini. And I think that's it today. We normally have our concrete crews out here just doing some miscellaneous stuff. They were out here a couple days ago backfilling the retaining walls along the runway. But obviously it's too muddy for them. So I think that's it as far as crew size today. There's only 14 guys. Whereas earlier this week, it was super busy. We had concrete guys. We had the block guys on, what was that, Chris, Monday or Tuesday? Monday, Tuesday, Wednesday, the block guys were here. So last week, that last building over there, what the block was maybe only 4 foot tall, 5 foot tall, and we got 2 lifts in between then. So that's how fast they're moving. They had the whole building scaffold. They did their last lift on what, Wednesday? Last lift on Wednesday. They took down their scaffolding yesterday, and now they're gone. They're done. So the block guys move super fast too. Yeah. No, so that's a good question. So on this project, and typically like what I see is the backfill, like, so on these retaining walls back here where you can see that little bit of block sticking up, all this paving is actually concrete paving. So our concrete sub owes the backfill on their side, and then on the other side, so anything that they need to put their concrete on, they backfill. But for the opposite side, like over here, that's actually our grading sub. That was actually a point of contention because our grading sub says, I don't do backfill, right? Because he was thinking like, it was like those where we have concrete or someone else coming after that. We're like, well, you own all the grading, right? So anything on that side where it's getting landscaping is by the grading sub. So we're working that out with him. But that's a really good question. For those of you guys, you know, that are going to be estimating and stuff, make sure you've got backfill covered. Make sure you've got off haul of any extra soil. So like all of your electrician, your plumber, they all take soil out of the ground, right? They've got excess soil. That all needs to go somewhere, right? So it's either going to get backfilled or it needs to get exported off site. All that costs money. Any other questions? You got anything to add, Chris?
No.
All right. Yeah.
What's your title?
So I own my own company.
Oh, okay.
And then I partner with Headwater. So it's like my client.
Okay, but I mean, like in terms of what we would put.
Oh, like you, but like project.
General, we can get any integrating of like forms. And one was like 2.5 feet. Get anywhere without
We only let it go up like this.